Welcome to 3 Steps to Sketch for Advanced Sine Graphs. So these are the sine graphs that are shifted. So either horizontally, we call that phase shifted for trig graphs, or vertically shifted, or both. Here's a general form equation for what that equation will look like, and we will talk about this in more detail soon. So the method that we'll talk about today is going to build on the method for basic sine graphs. So check that video out if you haven't already. The link will be in the video description. But we're going to take that and make a slight modification to that method so that we can deal with these shifts as well. All right, so here's our method. Step 1, we'll find our essential information. Step 2, we'll plot the base pattern. And in step 3, we will shift, sketch, and repeat. So again, this is very similar to our original basic sine graph method with a slight modification to step 3 where we will take care of the shift. And we'll delve into these steps in detail in just a few minutes. So before we get into the method, a quick tip that will help deal with some of the really advanced equations is to rewrite your equation to factor out your b term if needed. So our general equation looks like this, and if we factor out b, it looks a little messy right now, but with actual examples, this can be really, really helpful. So you might be thinking, okay, why would you make it look more complex? And it's so that we can clearly see our phase shift, which is going to be c over b. A really common error that people make is to assume that just c is the phase shift. So if asked just, here's an equation, what is the phase shift? They tend to just look at the c term and say that. Whereas if you always factor out that b term first, you'll clearly see the phase shift just staring at you in the equation. So this is not a necessity, but just something nice to know. So here's how that would look. Here's an example where we will rewrite the equation to factor out b. Okay, so we have y equals sine of 4x minus pi over 2. So we see clearly there's a shift. We see it in the input of the sine function, so right here. Okay, and we can see that's in the form bx minus c. So b is 4, c is pi over 2. Okay, but we want to factor out that b term, that 4. Okay, so to do that it's pretty simple. So we would say sine, pull out a 4 from the 4x, and to pull out 4 from pi over 2, all you really need to do is pi over 2 divided by 4. Okay, so that's actually pi over 8. All right, and you can always distribute that 4 back through to check yourself, make sure you factor it out correctly. And this way we can clearly see b is still 4, but our phase shift shows up right here. So we see that x minus pi over 8, so we would know our phase shift is clearly pi over 8 units, and we would be shifting to the right. This video specifically focuses on the method, and we'll jump into that in just a second. If you like the method, but you really need to see it in an example, I'm going to post a link to all different examples with cosine, so you can see this method working out some specific examples, and that will really set it into place. All right. So now let's go into step 1, find the essentials. And if you're familiar with the basic method, you'll see a lot of that you already know. All right, so here's a reminder of the equation, and I'm showing the one with b factored out just to keep everything consistent. So the first thing you want to do is analyze a, b, c, and d. Okay, so you'll have some horizontal transformations. Those are b and c. And the others, of course, a and d will be vertical, and we'll get to those in a moment. Okay, so b tells us how many cycles we have between 0 and 2 pi. And we can also use it to find the period of our equation, and all you do is 2 pi divided by b. The period is the length of one horizontal cycle. All right, and then we'll have c over b which we've talked about. You can see that really nicely in this factored form of the equation. That's your phase shift, and that's just another way to say horizontal shift for these periodic equations. All right, so our vertical transformations, like I said, are A and D, and just like with our basic equations, the absolute value of A will give us the amplitude, which is the distance from midline to maximum or midline to minimum. And then D is going to tell us our vertical shift. If you see, say, +1, you'd be moving up 1. If you see -1, you'll be moving down 1. All right, and then the last bit of essential information, this is your really last piece of setup. You'll find your scale labels. So this is what you're going to count by for labeling your tick marks on your axes. And we have a very particular way we do this with our horizontal scale labels. Take your period and divide by 4. And we do this design very intentionally. You could choose anything, but when you take your period and divide by 4, that ensures that you've broken the graph into 4 equal pieces. So all 4 of your key points in the base pattern in the next step will align with your horizontal tick marks. So that makes for a really nice and neat graph, and it just makes things a little bit easier overall. And then for your vertical scale, you can choose the absolute value of A and count by that. A lot of times I like to just count by 1, and that usually works very well. Okay, so the only new information here are the phase shift and the vertical shift. Okay, you'll notice all of these other pieces work for our basic sine graphs as well. So if you think about it that way, if you already are confident in graphing basic sine graphs or unshifted sine graphs, there's not much more that you have to tackle here. All right. Step 2 is to plot the base pattern. A reminder of our equation. So our base pattern for sine, this is unreflected sine, just a parent y equals sine graph, sine x, is 0, 1, maximum, 0, 2, minimum. And remember, 0 is just another way to say x-intercept. And so those are your 4 key points in your base pattern. And if you want to specifically have a template for finding those, your 0, 1 will start at 0, 0 for your unshifted graph. We'll take care of those shifts later. Okay, your maximum will happen at your first horizontal tick mark to the right of the origin, and its y-coordinate will be A. The second 0 will happen at the second horizontal tick mark, still moving to the right. And your minimum will happen at the third horizontal tick mark, and the y-coordinate value will come from just the opposite of A. Okay, so this is what you work with if you have an unreflected, so no negative out front, sine equation. Okay, and that's what that says if A is greater than 0. Now, if A is less than 0, that means you have a reflection vertically that reflects everything over the x-axis. Your template above will still work the exact same. You simply need to relabel your pattern name. It would be 0, 1 minimum, 0, 2 maximum. Okay, but the pattern template will still work in order to find that. It's just you would see that on your graph. You would see, oh, look, that's a minimum first instead of a maximum. Okay, one final note, a good tip here. So in step 2, we're graphing the base function, and that's without the shifts. So really that's the equation y equals a sine bx, and that's the basic unshifted sine equation that we are familiar with. We're going to apply our shifts in step 3. So step 3 is to shift, sketch, and repeat. So the shift is really the only new part. Here's our equation. You'll apply your shifts, your phase shift, which is C over B, and we can see that clearly in our equation. Your vertical shift D, usually you can accomplish both of those together. You just take your base pattern points and you move, say, right and up. You'll sketch the graph in, so you'll sketch in the sine curve connecting all your final points, and then you'll repeat that pattern, your final pattern, to get as many cycles as you want. So that's really all there is to it. Here's this information condensed down into a template that you can use every single time. Remember that there will be links in the description for this video that will take you to examples where you can see this worked out for specific equations. I think watching those can be really, really helpful to set this method into place. But you'll notice that step 1, this portion right here is all of the information that we would find for the base graph, which we use in step 2. Okay, and that's very much almost exactly identical to the method for basic sine graphs or unshifted sine graphs. You'll see that the shifts are right below. So when you're finding the essential information, it makes sense to just order it so that it falls in line. The shifts happen in step 3. Okay, so that's your new piece for this more advanced method. So now, without working a specific example, I want to show you briefly what this is going to look like. So let's just throw onto the graph the sine base pattern. So say you found all the essential information. I'm not going to fill it in with specifics here, but do check out the examples. Okay, a basic sine pattern would be 0, maximum, 0, minimum, and then you'd start your repeat. Okay, and so when you're plotting the base pattern, make sure you do that lightly. Those are not your final points. Okay, you are going to want to shift them in step 3. So let's just say we knew our phase shift was right 1 grid unit and up 2 grid units. You would take each of your blue or lightly marked points and you would shift them right 1 grid unit and up 2 and darken those. Those will be part of your final graph. So for each one, you'll move them. In this case, we assumed right and up, however many units for each. Okay, and you can see your graph, your final graph, the shifted one, is appearing with green dots. So your sine graph would look something like that. Okay, and of course you could repeat. This is just to show you how you'll accomplish it. So step 2 is kind of that intermediate, lightly mark that graph, and then step 3, you will shift. And I usually like to use a different color just so I can keep everything straight. All right, so this was a breakdown of the 3 steps to sketch for advanced sine graphs, your shifted sine graphs. Take a look at the links in the video description to see this method used with more examples. Really digging into the examples will help set everything into place, will clear up any points of confusion. This does take a little bit of practice, but once you've got it, this method will work for you every single time. Thanks for watching.